Orbiting Jupiter are four of the most extraordinary moons in the solar system: Io, Europa, Ganymede, and Callisto. These Galilean moons, discovered by Galileo Galilei in 1610, are not mere satellites. They are complex, dynamic worlds in their own right, each one unique in its geology, composition, and scientific potential. At Infinity Beyond, we often say that if you want to see the diversity of planetary environments, you don't need to leave Jupiter's neighborhood. Let's begin with Io, the innermost of the Galilean moons. Io is the most volcanically active body in the solar system. Its surface is a chaotic landscape of sulfur plains, lava lakes, and erupting volcanoes. These volcanic plumes can rise hundreds of kilometers into space. What drives this incredible activity is tidal heating. Gravitational forces from Jupiter and neighboring moons flex Io's interior, generating enormous friction and heat. Io has no known subsurface ocean, but its volcanic processes offer insights into the internal dynamics of rocky worlds. Next is Europa, perhaps the most tantalizing moon in the search for extraterrestrial life. Covered in a smooth shell of ice, Europa conceals a vast subsurface ocean, one that could be as much as 100 kilometers deep. This ocean is kept liquid not by sunlight, but by tidal heating. Europa's cracked and ridged surface suggests that the ice is dynamic, moving and flexing as the interior warms it from below. Observations from the Hubble Space Telescope and the Galileo spacecraft suggest that water plumes may be erupting through the ice, offering a direct path to sample the ocean without having to drill. If microbial life exists anywhere in the outer solar system, Europa is a prime candidate. Its ocean may be in contact with the moon's rocky mantle, potentially enabling hydrothermal vents similar to those found in Earth's deep oceans, ecosystems that thrive without sunlight, using chemical energy instead. The upcoming Europa Clipper mission will investigate these possibilities in detail, scanning the ice, probing for signs of habitability, and seeking the building blocks of life. Then there's Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. Ganymede is unique among moons because it has its own magnetic field, likely generated by a liquid iron or iron sulfide core. This field interacts with Jupiter's powerful magnetosphere, creating auroras that dance across its poles. Ganymede, too, is believed to harbor a subsurface ocean, possibly layered between sheets of ice. Its surface is a mix of dark, ancient terrain and lighter grooved regions, shaped by tectonic activity. Ganymede is a frozen world, but not a still one. Lastly, Callisto sits farthest from Jupiter and is the most heavily cratered object in the solar system. Its battered surface has remained largely unchanged for billions of years, preserving a record of the early solar system. Despite its apparent geologic inactivity, Callisto may also possess a subsurface ocean. Its distance from Jupiter shields it from intense radiation, making it a candidate for future human bases, should we ever venture that far. Together, these moons showcase a spectrum of planetary possibilities: volcanic fire, icy oceans, magnetic fields, and ancient records. They remind us that not all potentially habitable worlds are planets, and that in the shadows of giants, life might quietly stir. At Infinity Beyond, the Galilean moons are a solar system within a solar system, 4 worlds orbiting one, each pulling us deeper into questions of habitability, geology, and life. As we send more missions, capture more data, and one day perhaps even land on these distant shores, we edge closer to answering a question that has echoed across centuries. Are we alone? Beyond the orbit of Jupiter lies one of the most visually breathtaking worlds in the solar system, Saturn. With its iconic rings and otherworldly moons, Saturn captivates both scientists and stargazers alike. At Infinity Beyond, we regard Saturn not only as a giant of gas and gravity, but as a symbol of cosmic elegance, a planet that reveals how beauty and mystery often go hand in hand in the universe. Saturn is the second largest planet in our solar system, yet it's the least dense. So light, in fact, that it would float in water if there were a bathtub large enough to hold it. Composed mainly of hydrogen and helium, Saturn is similar in structure to Jupiter, though its atmospheric patterns are more subtle. Beneath its golden clouds, however, lies a planet of complex storms, including a massive, persistent, hexagonal jet stream at the North Pole, a geometric structure that has baffled scientists since its discovery. But Saturn's most famous feature, without question, is its rings. Unlike the faint ring systems of other gas giants, Saturn's rings are vast, bright, and intricate. Spanning over 280,000 kilometers, about 175,000 miles, but just tens of meters thick, they are composed mostly of ice particles, from tiny grains to massive chunks the size of houses. The origin of these rings is still debated. They may be remnants of a shattered moon, torn apart by Saturn's gravity, or they may have formed early in the planet's history from leftover material during its formation. Though visually stunning, Saturn's greatest scientific treasures may lie among its moons, and it has more than 150, including provisional ones. Two stand out as especially fascinating: Titan and Enceladus. Titan, the largest of Saturn's moons, is unique in the solar system. It's the only moon with a thick atmosphere, denser than Earth's, and it's composed primarily of nitrogen, with traces of methane and complex hydrocarbons. The surface of Titan is cold, averaging 179 degrees, 290 degrees, but it hosts lakes and rivers, not of water, but of liquid methane and ethane. Radar mapping has revealed mountain ranges, dune fields, and even rainstorms. It's an alien world with a familiar hydrological cycle driven not by water but by hydrocarbons. Beneath Titan's icy crust may lie a vast subsurface ocean of liquid water and ammonia. This makes Titan a potential candidate for life, not just in its ocean, but also in its complex chemistry. The upcoming Dragonfly mission, set to launch in the 2030s, will explore Titan's surface with a rotorcraft lander, studying its chemistry and searching for signs of prebiotic processes. Then there is Enceladus, a small moon with an outsized impact. Despite its modest diameter of just 500 kilometers, 310 miles, Enceladus has become a key target in the search for life. In 2005, NASA's Cassini spacecraft discovered massive geysers erupting from its south pole, jets of water vapor, ice, and organic molecules shooting into space. These plumes originate from a global subsurface ocean, kept warm by tidal forces from Saturn. Cassini flew through these plumes multiple times, sampling the spray directly. It detected salts, simple and complex organics, and evidence of hydrothermal activity on the seafloor, conditions that on Earth support entire ecosystems. If life exists in Enceladus's ocean, it could resemble microbial life found near Earth's deep-sea vents. At infinity beyond, Saturn is more than just rings and clouds. It is a system teeming with possibilities. From the methane seas of Titan to the icy fountains of Enceladus, Saturn challenges our assumptions about where life could exist and reminds us that the solar system is far more diverse and more alive than we once imagined. As we voyage beyond Saturn's magnificent rings, the outer reaches of our solar system begin to take on a strange and haunting beauty. Here lie the ice giants, Uranus and Neptune, two worlds that defy expectations and continue to perplex scientists. At infinity beyond, we regard these distant giants as cosmic enigmas, planets that hide powerful secrets beneath their icy exteriors and turbulent skies. Uranus, the seventh planet from the Sun, is often overlooked in favor of flashier worlds, yet it is one of the most bizarre planets in the solar system. Tilted at an angle of nearly 98 degrees, Uranus essentially rolls around the Sun on its side. This unusual axial tilt results in extreme seasonal changes that last over 20 years, with one hemisphere bathed in constant sunlight and the other plunged into prolonged darkness. Its pale blue-green hue comes from methane in its atmosphere, which absorbs red light and reflects blue. But beneath this calm exterior lies a surprisingly dynamic and mysterious world. Uranus is composed mostly of hydrogen, helium, and a dense mix of water, ammonia, and methane ices. It is surrounded by a faint set of rings and has at least 27 known moons, some of which may have been captured from the Kuiper belt. What's most puzzling about Uranus is its internal structure and magnetic field. Unlike Jupiter and Saturn, Uranus seems to lack the same intense internal heat. It emits very little energy. Its magnetic field is wildly tilted and offset from the planet's center, suggesting a strange internal dynamo. Scientists believe that beneath the upper atmosphere lies a supersonic ocean, a bizarre phase of water that conducts electricity like metal. Then there's Neptune, the eighth and farthest known planet from the Sun. Slightly smaller than Uranus, but more massive, Neptune is a vivid blue world with some of the most violent weather in the solar system. Winds on Neptune can exceed 2,000 kilometers per hour, 1,200 miles per hour, making them the fastest recorded in the solar system. Its atmosphere hosts massive dark storms, analogous to Jupiter's Great Red Spot, that appear and vanish over time.